Sequences of functions. We've got a list of numbers like 3, 5, 7, 9, 11, or a list like 1, 5, 13, 29, 61. It's called a sequence. There are many ways to define a sequence, but one way is to describe how each term relates to the one before it. For example, the first sequence can be described this way. The starting term is 3, then each following term is 2 more than the one before it. The second sequence up there can be described as the starting term is 1, then each following term is the sum of 3 and twice the previous term. A sequence is defined as a list of numbers, while a term of a sequence is one of the numbers in the list. Now, take a look at these three sequences. What do you notice about each pattern of squares? I would like you to pause the video at this point in time, and I would like you to, in your OneNote, just write what you notice about each of the sequences, A, B, and C. And then I would like you to, when you finish writing, unpause the video, and we'll move on to the next piece. Okay, you've unpaused the video. Now the next piece is again looking at those three sequences. Take a moment, pause the video, and write down in your OneNote, describe how to get the next term in each sequence. Give me the rule to get from term 4 to term 5 in each of the sequences. Once you've got that done, unpause the video and continue. Okay, you've written how to get the next term in each of the sequences, and you've written that in your OneNote. Now, moving on, we're going to explore each of these. So the first one, I've got it from the image there. I've created a table. First term, so what term it is on the left, that's our x, and the second f of x is how many squares for that term. So if you notice, the first one is 1, the second is 3, the third is 5, and the fourth is 7. Now how we're going to identify some key characteristics is we're going to note some things about the pattern. So one of the first things we do is we look at first differences, and that works really well in a table. So notice between the first number of squares and the second number of squares, to get from 1 to 3, we add 2. What do we do to get from 3 to 5? Add 2. 5 to 7, add 2. Second differences. What do I do to get from plus 2 to plus 2? I add 0. Plus 2 to plus 2, again, add 0. So our first differences are all the same. They're all plus 2. Our second differences are all 0. That means this is a linear function. It grows at a linear constant rate. Or it's called an arithmetic sequence because we keep adding something to get the next term. Now we can use that first and second differences to help us find the fifth term. We can also use it to help us get the 0 term. So first differences should be plus 2, second differences should be plus 0. So what's 7 plus 2? 9. Go backwards for 0. First difference we should be adding 2, second difference should be adding 0. So instead of going forward, it's basically I have 1. How do I undo adding 2 to get to the term before it? Well, instead of adding 2, we would do the inverse operation. Subtract 2. 1 minus 2 is negative 1. That's kind of hard to show in visuals. How do you show a negative 1 square? That's where the representation, table representation, doesn't match real life. But again, that's one of the things that we do. We use math to model real life. Doesn't mean it fits it exactly. It means we get close, and we have to pay attention to what parts we can use and what parts we can't. A verbal rule for what we do to get from one term to the next would be add 2 to the previous term to get the next term in the sequence. It would just be a quick verbal how-to. Now the next one, sequence B, again, I've done the same thing. Here I've labeled it a little bit differently. The first column's n for the number of term, and f of n is how many squares for that term. First term there's 2, second there's 4, third there's 8, fourth there's 16. Still going to do first and second differences. First differences, to get from 2 to 4 we add 2. 4 to 8 we add 4. 8 to 16 we add 8. second differences. To get from 2 to 4, we add 2. To get from 4 to 8, we add 4. Kind of notice first differences are different, second differences are different. Okay. We're actually multiplying to get to the next term. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That means it's an exponential or geometric sequence. And we can use that pattern to help us figure out the fifth term. Fifth term, the next in the second differences would be plus 8. That means the first differences would be plus 16. 16 plus 16 is 32. Go backwards for the 0 term. That means instead of multiplying by 2, we divide by 2. 2 divided by 2 is 1. That means to get from 1 to 2, the first difference would be plus 1. The second difference would also be plus 1 to get from 1 to 2. General verbal description of the pattern, multiply by 2 to the previous term to get the next term in the sequence. Now let's look at the third one. Now let's take a look at that third sequence. So we've got our first term has 1. Again, I've used the table format. Our number of term is x. Our number of squares for the term is d of x. Our first term has 1 square, our second has 4, our third has 9 squares, our fourth has 16. Working with our first differences, 1 to 4 is plus 3, 4 to 9 is plus 5, 9 to 16 is plus 7. Second differences, 3 to 5 is plus 2, 5 to 7 is also plus 2. So right there we can really easily see that the first difference is not the same. Second differences are all 2. They are the same. That means when the second differences are the same, it's quadratic. Okay, so think about that just a little bit. On our first one, A, that was linear. Our first differences were the same. On C, the second differences are the same and it's quadratic. Linear is x to the first power. Quadratic is x to the second power. Can you make a prediction about the third differences and the fourth differences and so forth and so on? Okay. General rule for this one's a little harder, but we can kind of take a look. I don't have this one written, but looks like we're squaring each term. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Kind of means we can get the fifth term. Our second difference is plus 2. That means our first difference would be plus 9. 16 plus 9 is 25. 5 squared is 25. Go backwards. 0 plus 2 and 3 take away 2 should be 1. That means we go backwards from the first term having 1 square, go back 1, subtract 1, would be 0. And that makes sense. 0 squared is 0. Now let's kind of put this all together in a quick and easy to find format. So arithmetic, aka linear, degree of x is 1. Quadratic, degree of x is 2. And geometric, aka exponential. On an arithmetic or linear, the first differences are the same, the second differences are 0. On quadratic, first differences are different, second differences are the same. Geometric, first differences are different, second differences are different. Verbal description for arithmetic, add or subtract to get the next term. Quadratic, we really don't have one, although we do know that we're going to be squaring something. Geometric, multiply or divide to get the next term. Recursive description. Recursive is how do I take a previous term and get the next term? So we start with our first term, f of 1 equals a sub 0. Okay, that's using a subscript. Okay, and to get f of n, we take f of n minus 1. N minus 1 means the previous term, and plus d. D, and we usually start with this n greater than or equal to 1. D is our common difference. That's what we're either adding or subtracting. For geometric, f of 1 again is a sub 0. And here we take the previous term times r for n greater than or equal to 1. R is the common ratio. Explicit is basically the formula. You don't have to tell what the first term is. You can plug in any number for x and you'll get the equation. F of x equals dx plus a sub 0. X is the term. D is the first common difference. A sub 0 is the zero term. It's the y-intercept. Quadratic, f of x equals ax squared plus bx plus c. How do we get that from the descriptions? From the list of values is a little bit different. F of x equals a sub 0 times r to the x. X is the term. A sub 0 is the zero term. R is the common ratio. Fill that in on your table. That's what I'm looking for first day notes.